to the Learning Zone. This is Mr. B. In this video, I'll explain how to calculate the average atomic mass of an element. The average atomic mass of all known elements may be found on the periodic table. When calculating the average atomic mass of an element, two sets of data must be provided. The actual mass of each isotope of that element, as well as the percent abundance of each isotope. Consider the following example. Based on the data below, calculate the average atomic mass of magnesium, where we're given three isotopes, Mg24, 25, and Mg26. We're also provided the percent abundance of each isotope, as well as the actual mass of each isotope, where both sets of data may be determined by a process known as mass spectroscopy. The first step is to convert the percent abundance values to a decimal. By doing so, we are creating what is known as the fractional abundance of each isotope. To convert a percentage to a decimal, we simply divide each percentage value by 100. So for Mg24, which has a percent abundance of 78.99, the fractional abundance becomes 0.7899. For Mg25, 0.1000, and for Mg26, 0.1101. Now that we know the fractional abundance of each isotope, we will begin the calculation. To do so, we simply multiply the fractional abundance values times the actual mass. In the case of Mg24, we multiply 0.7899 times its actual mass, which is 23.98504. This will yield a mass contribution for Mg24 to be 18.9457831. For Mg25, 0.1000 times 24.98584. This will equal 2.498584. And finally, for Mg26, 0.1101 times 25.98259 will equal 2.860683. Now let's apply the rules of significant figures, where according to the rules of significant figures, when multiplying two measurements, the product must have the same number of digits as the measurement or value with the least number. Clearly, in all cases, the fractional abundance will have four significant figures. Therefore, each product must be rounded to four sig figs. For Mg24, the mass contribution becomes 18.95. For Mg25, 2.499, and for Mg26, 2.861. Now we simply add the mass contribution of each isotope. 18.95 plus 2.499 plus 2.861 will equal 24.310. However, according to the rules of significant figures, when adding measurements or values, the answer may not exceed the number of decimal places as the measurement with the fewest number. In this case, 18.95 has two decimal places, 2.499 has three decimal places, and 2.861 has three decimal places. Clearly, the magnesium-24 mass contribution has the fewest number of decimal places. So we round our answer to 2 decimal places. Therefore, the average atomic mass of magnesium, based on this information, will be 24.31 AMU. By using this simple technique, you will also be able to calculate the average atomic mass of any element. Thanks for watching.